For the past 2 years, the biggest winners in AI have been chip companies. But now, a new problem is emerging. Buying chips is one thing, deploying them is another. While the industry pours billions into liquid cooling and data center upgrades, Supermicro is taking a completely different approach. No liquid cooling, no data center rebuilds, just plug in and deploy. Could this change the future of AI infrastructure? Hi everyone, this is Stock Market Breakdown. If you want to go beyond just watching price moves and actually understand the logic behind the market, make sure to like and subscribe. Let's dive right in. As AI inference demand continues to grow, more companies are trying to bring AI into real-world production environments. The problem is that many existing data centers were never designed for high-density AI workloads. Deploying next-generation AI servers often requires power upgrades, cooling modifications, and sometimes a complete redesign of facility architecture. These projects are expensive, time-consuming, and increasingly becoming one of the fastest-growing areas of AI-related capital spending. Supermicro's new EPYC platform was specifically designed to address this challenge by allowing enterprises to deploy AI compute using existing air-cooled infrastructure. Many investors think AI competition is simply a chip competition, but for enterprise customers, the more important question is, how quickly can those chips start generating value? If one solution takes a year to deploy while another can be operational within weeks, the faster option often becomes far more attractive. That's why deployment efficiency is becoming just as important as hardware performance. At the heart of this system are dual AMD EPYC 9000 F5 series processors. Over the past few years, most attention has been focused on EPYC, but as AI shifts from training to inference, CPUs are becoming increasingly important again. In real-world workloads, CPUs manage data movement, network communication, storage coordination, and workload scheduling. As enterprises run more complex AI applications, reliable data processing and system orchestration become critical. In modern AI servers, CPUs are no longer supporting players, they're foundational components of the entire platform. A lot of people think AI is simply a GPU game, but EPYCs handle computation. CPUs manage the system. If data can move efficiently, even the most powerful EPYCs won't reach their full potential. The future of AI infrastructure won't be determined by individual chips alone. It will be determined by how well the entire system works together. Beyond CPUs, one of the most important jobs of an AI server is connecting large numbers of EPYCs. As models continue growing in size, more workloads require multiple EPYCs working together. If data transfer becomes a bottleneck, expensive EPYCs end up sitting idle while waiting for information. Supermicro's platform supports high-density GPU configurations and uses an optimized architecture designed to reduce bandwidth constraints. For inference workloads, consistent throughput and sustained performance are often more important than short bursts of peak performance. As a result, server architecture itself is becoming a major factor in overall AI system efficiency. In the future, enterprises may care less about how many EPYCs a server contains. Instead, they'll care about how effectively those EPYCs are being utilized. When organizations deploy hundreds or even thousands of EPYCs, improving utilization by just a few percentage points can translate into millions of dollars in savings. Today, much of the industry believes liquid cooling will play a major role in the future of AI data centers. But for many enterprises, a full transition to liquid cooling still requires significant investment and operational complexity. As a result, air cooling hasn't disappeared. In fact, for many inference-focused deployments, air-cooled systems that work with existing infrastructure still offer meaningful advantages. Companies can deploy next-generation AI servers without spending billions on facility upgrades. As AI adoption continues to expand, deployment cost is becoming a major competitive factor. and solutions that lower deployment barriers are attracting increasing attention. The future AI market probably won't have a single infrastructure model. Liquid cooling makes sense for massive training clusters, but air-cooled systems may be a better fit for many enterprise inference deployments. Different use cases will ultimately require different solutions. This platform also supports AMD's latest Instinct MI350P as the AI industry gradually transitions from training to inference. Demand for high memory and high bandwidth accelerators continues to grow. More companies want to run larger models while reducing latency and operating costs. As a result, platforms capable of supporting large-scale model deployment are receiving increasing attention. The industry's focus is shifting away from pure training performance and toward inference efficiency and long-term return on investment. For enterprise customers, sustainable inference capability may ultimately matter more than peak benchmark performance. Over the past few years, most of the conversation has focused on training AI models, but inference is where recurring revenue gets generated. Every user query, every AI assistant response, every autonomous agent action, all of it requires ongoing compute resources. That's why inference infrastructure could become one of the most important AI investment themes of the next decade. From a broader perspective, the AI industry is undergoing a major transformation. The focus is expanding beyond individual chips and toward the entire infrastructure ecosystem. Servers, power systems, cooling technologies, networking architecture, and data center construction are all becoming critical drivers of AI growth. As enterprises enter large-scale deployment phases, solutions that reduce costs, shorten deployment timelines, and improve resource utilization could receive increasing attention. The next phase of AI competition won't just be about GPU performance, it will also be about infrastructure efficiency. AI's next growth cycle is spreading beyond chips and into the entire infrastructure stack. If the last 2 years were about CPUs, the next few years may be about AI infrastructure, because CPUs only create value when they're deployed. Wall Street chase chip makers. The next winners may be the companies enabling AI deployment. So, where is the biggest AI opportunity ahead? Chips, servers, power, or data centers? Let me know in the comments. Subscribe to Stock Market Breakdown, and I'll see you in the next one.